All right, hey guys, we're going to simplify some more. I think I kind of cut off short yesterday just because I didn't want the video to get too long. So we're going to simplify some more. Can you get things as simple as possible? I know that sometimes when we are verifying stuff in Trig, that was always kind of, can I go any farther? Is this as simple as it wants it? So in general, you're looking for, if it's a fraction, to get one numerator and one denominator, everything being together. Okay, so here we go. We're going to start with a over x squared plus b over x divided by m over x squared plus k over xc. And I want you to simplify this as much as you possibly can. Okay? Now, I will tell you what I would do. What I would do is take the top and simplify it as much as I can, take the bottom and simplify it as much as I can, and then combine them. Okay, meaning divide the top by the bottom. So in the top, I'm probably going to get common denominators. Looks like my common denominators are probably going to be x squared, so x times x. So it should just be one of these that I have to multiply by. Okay, so the top should become a plus bx over x squared. Pretty much as simple as I can make the top. What about the bottom? This time I have an x squared and an xc. So I need the x squared, but I also need the c. So I'm going to have to multiply the left one by a c, so I would have an x squared c. And the right, I need another x to have an x squared c. Okay? So here we go. The bottom. It's going to look like my denominator is going to be x squared c, and my top is going to be mc plus kx. And then I've got this division line in between them. Okay, so I've got simplified fractions on the top and the bottom with common denominators. Now, what do we do with a fraction divided by another fraction? Yeah, you said it. We're going to keep change flip. A plus bx over x squared times x squared c over mc plus kx. So keep change flip the second number, multiply by the reciprocal, whatever you say, that's what we're doing. Now, I like to simplify before I multiply. Do you? It doesn't matter. It's okay if you do. Now, some things can be simplified. If you have something being multiplied, that we can reduce going that way, meaning x squared divided by x squared is simply going to be 1. Okay? Just because this I can reduce. Okay? Now, what can we not reduce? There's a c here and there's a c here. Can I reduce those c's? No, you cannot. Why? Why not just mark those c's out? One's on the top and one's on the bottom. Because there's not a c in every piece of the term. Every term. Okay? If there had been a c right here with this term, then yes, you could have reduced. But since there is not, you cannot reduce them. Okay? Just like this x right here and this x right there. There's one on the top and one on the bottom. But unless it's a piece of every term, unless x is part of every term, you cannot reduce it. The only reason we could do the x squared is because this was a multiplication sign. There was no addition in between them. If it had been, we wouldn't have been able to reduce that either. Okay? So, after we've done that, our one reducing, let's see what do we have left. Now this c is going to have to be multiplied by everything. So now I have an AC plus, I'm going to put it in the middle because alphabet, BCX divided by my bottom here, which is MC plus KX. Now I have C's in 3 of my 4 terms. Can I reduce? No. You cannot. You have to stop. That is as simple as we can make it. Okay, does that make sense? There are rules about things you can reduce and things you can't reduce. All right. I feel like we probably should do another one. Yeah. I don't know. I think you've got it. So we're not going to. I know that just made you so happy. But guess what? Now we're going to move on to some square roots and simplifying square roots with their square roots of things. And I know that you probably have these, but we're just going to do one or two. 4 plus the square root of 2 over 3 minus 2 on the square root of 2. Okay? Simplify. What do we do when we have square roots in the denominator? Is that ever allowed? No, it's not. So what do we do when we have square roots in the denominator? Yeah, I heard you say we must rationalize them. Now, the big question is, can I simply multiply by the square root of 2 over the square root of 2 and get the square root of 2 out of the denominator? Is that possible? Well, there's something that we have to do that we've done several times. Maybe you've paid attention and maybe you haven't. We must distribute things, right? So here on the top, not worried about that, going to distribute. Now the issue on the bottom, I'm going to have a 3 times the square root of 2. I'm adding a 1. So I'm just moving the square root of 2 to another place. This is not how we're going to get rid of that square root, okay? There's another word, and you may remember it or you may not remember it from Algebra 2. Yeah, okay, somebody said it. We are going to conjugate. I think that's how you spell it, if that's an E, conjugate. How do you conjugate in math? You conjugate the denominator. And it's supposed to be a U instead of an E, I think, anyway, yeah. So I tried to fix it so you could see that it was an E and it should be a U. It's okay. Conjugate, it's not conjugate. So how do we conjugate a denominator? We're going to multiply it by, you're only looking at the denominator. That's all you need to get the square root out of. We're going to multiply by the exact same denominator, except for we're going to change the sign in the middle. Okay? And whatever you multiply the bottom by, you have to multiply the top by. Okay? Now we're going to have to distribute or FOIL in this case. I'm going to go kind of slow just in case you forgot. First is 12, 4 times 3. Outside, 4 times 2, root 2. So that's going to be plus 8, root 2, or square root of 2. That's my outside. My inside, square root of 2 times 3 is plus 3, square root of 2. And then the last, 2 times square root of 2 times square root of 2, I think, because becomes 2 times 4. Sorry, 2 times the square root of 4, which is 2. 2 times 2 is 4. Okay, I know that we can simplify that, but I'm going to move on to the bottom. Okay, I'm going to do the same thing. The first, 3 times 3 is 9. The outside, 3 times 2 root 2 is 6, root 2. Inside, negative 2 on the root 2 times 3 becomes negative 6, root 2. And then our last, negative 2 root 2 times 2 root 2 becomes 4 times root 4. So 4 times 2 is 8. Okay, so that is FOILing the top and the bottom. I know you can do it quicker. Please do. I won't do it like this forever, but it may have been a while. Some things that we can combine on the top. What's 12 plus 4? Yeah, that's 16. What about these two? Can we combine those two? Simplify it. 8 root 2 plus 3 root 2 is 11 root 2. Correct. What about our denominator? Well, what about this one? And this one. What's 9 minus 8? 1. What's 6 root 2 minus 6 root 2? They are 0. So this one is nice that my denominator, our denominator, is simply 1. So our answer is simply 16 plus 11 root 2. We have simplified it. Okay? We're done. Woohoo! Wonderful. We're going to do one more. That's square roots. It's going to be a little bit different, but kind of the same. I don't know. 3 square root of 3 over 2 minus 4 times the square root of 2 over 3. Oh, it wasn't plus. I've done that a time or two. Minus the square root of 24. And I want you to simplify. Okay, so let's go ahead and simplify. Well, how in the world do I simplify this? Well, number one, you have to remember that square roots, when you have a square root and a fraction in the middle, it's really the square root of 3 over the square root of 2. Yes? Of course. And can we leave square roots in the denominator? So now I've got 3 times root 3 over root 2. Should I rationalize? Yeah, and really all I care about is the denominator. Okay? So now this 3 kind of sometimes gets kids a little lost. It really is a fraction, 3 over 1. So 3 over 1 times the square root of 3 over square root of 2 times the square root of 2 over the square root of 2. You've got 3 fractions multiplied together. So I'm just kind of looking at this first piece, see if we can get an answer for it. Okay? So now we have 3, and then can we simplify with our square roots? Because those are things we can combine, right? Yes. So we have 3 root 6. Square root of 3 times the square root of 2 is the square root of 6. Now, what about the square root of 2 times the square root of 2? Simply 2. Okay, so we've got an answer for the first piece. Can we get an answer for the second piece? Okay, we're going to do almost the exact same thing. We can look at the 4 over 1 times the square root of 2 over the square root of 3. Should we rationalize with the square root of 3 over the square root of 3? Of course we should. I mean, this is all minus. So now I'm going to simplify this to 4 root 6 over 3. Okay? And last but certainly not least, the square root of 24. There's no numbers around it, but should I break it down? Of course you should. You should simplify the rational. Okay, so we know the square root of 4 times the square root of 6, correct? So the square root of 4 is 2. Square root of 6 we can't simplify anymore, so we leave it minus 2 root 6. Now, does anybody notice anything special? I'll go ahead and put this over 1 because I know that everybody sees fractions. But do you see a square root of 6, a square root of 6, and a square root of 6 that we can combine together? Yes, we can. Now the only thing standing in our way is those pesky denominators, right? So I'm going to erase my circles. So, common denominators. What would be my common denominator between 2, 3, and 1? Yep, it is 6. So I want to multiply the 2 by 3 over 3, the 3 by 2 over 2, and the 1 by 6 over 6. So now my denominator will become 6 under all of these. All right, so let's simplify. I now have 9 root 6 over 6 minus 8 root 6 over 6 minus 12 root 6 over 6. So now my numbers are the only thing that I can multiply together. The 3 and the 3, the 2, 4 and the 2, and the 2 and the 6. Okay, so now I have all common denominators on the bottom, so my answer will have a 6 underneath it. Can I simplify? 9 root 6 minus 8 root 6 minus 12 root 6. Yes, I kind of forget about this root 6, the square roots. And so what's 9 minus 8? We have 1. 1 minus 12 should be negative 11, right? And then that root 6 is out there. You have simplified another rational. Okay? Are you good? I'm going to leave you with two problems. Maybe 3. Actually, we're going to do 3. Sorry. 3 problems for today. The first one will be, we're going to do a plus, they're all going to be similar to what we did today, 1 over a plus 1 over a. That one's not too hard. We're going to do, number 2, we're going to do an x squared y over 1 plus m squared plus x over y. Okay, so all of these are going to say simplify, all of them. Sorry. Number 3, we're going to do 4 minus 3 root 2 over 8 minus root 2. Okay, and we're going to stop right there. Yeah, 3 problems is enough. I will talk to you later. You guys are awesome. Text me with any questions, and good luck.